So now that we've analyzed each particular element in our design and we've looked at everything that that element needs and everything that it gives us, then we need to start looking at what is that element best connected to? Where should we put that element? What can that element be of benefit to? We can use the slope to our benefit. It's easier to roll things downhill. We can look at the landscape itself and figure out where those elements are best placed. So when we do this, we want to see how much attention does each one of these elements require. And the main question that we want to have in our mind is, how many visits per year does this element need from us? We want to be very efficient here. We do not want to place things really far away that we need to access all the time. So going back to our chicken example, most chickens will be visited about 800 times per year. It's going to be pretty much twice per day, plus a little bit more here and there when you are dealing with predators or sick chickens, broody chickens, whether you're collecting eggs, letting them out, closing them in, feeding them once or twice a day. And looking at how often we see a lot of these elements, this is going to change where we place the element. So, for example, if we have a chicken coop and this is our house and it is 500 meters away from our house, then if we visit it 800 times per year, that is 400 kilometers per year that we are walking just for our chickens. That is a really, really big waste of our energy. And so although not very many people are going to want them extremely close to their house, we do want to take into account that we want them a lot closer by. So they can be quite dirty and smelly, but they do make really great heaters for greenhouses or polytunnels. They have been used under the benches in greenhouses. So you can also connect a chicken coop to a greenhouse. So when we look at the chicken coop connected to the greenhouse, the heat from the chickens, it rises into the greenhouse. Although we may not want to connect them to our house, we may want to connect them to our greenhouse. So in this example here, this is actually from the Introduction to Permaculture book by Bill Mollison. And although there's a lot going on in this picture, what we really need to look at is just the benefit here to the greenhouse by the chickens. So the chickens are living on this side here in their chicken coop, and the greenhouse is on this side here. So if we combine these two elements, then the heat from the chickens, which happens to be right underneath the planting area, the heat from the chickens will rise up into the greenhouse and help to heat it. So they can be useful connected to some buildings, but not necessarily our home. So chickens can also be noisy. Often they're on the edge of a garden. They usually go out into the larger system, like a foraging area of maybe a food forest or something, but they don't go in the garden themselves. So if we look at other elements, like a very large timber tree, you likely won't use it until it's about 50 years old if you're growing it for timber. You may need to prune it every couple of years, but you won't need to be visiting it on a regular basis. Once you plant it, you may need to water it now and again during its first year, but you may only visit it 3 to 5 times that year. And that's something that you really want to place 500 meters away or more, because you're not going to be needing to visit it and it's going to take up a lot of space. If you put that same timber tree in the middle of your vegetable garden, not only will it rob it of nutrients, but it's also going to take up so much valuable space that's very, very close to your home. So if you want something to be nearby, it has to be very fast and very productive. such as annual vegetables or even perennial herbs or something like that. So each one of these elements really needs to be analyzed carefully. So how many visits per year does it need from us? And then once we've established that, we also need to take into account orientation. So the orientation is looking at which way does our yard face. This determines how and where we are going to place things. So in the southern hemisphere, we orient our design towards the north, which is towards the sun. And the sun will go from right to left as you face the sun. In the northern hemisphere, we want to look at facing our design towards the south. So this seems quite backwards from the way that we normally would do this, because we are then actually, because normally when we're looking at a map, obviously north is usually up on our map. And this time we're going to be usually putting south to the top of our map because we want to face everything towards the sun. That's how we want to work our orientation. So when we do this, the sun's going to move from left to right as we're facing the sun. We know when we're looking at the sun that the slopes that face the dawn, so in the case of the northern hemisphere, any slopes that are facing slightly southeast, they're not going to get as hot, they're not going to get as much of the sun's energy as the slopes that face the afternoon sun, so the slopes that face the southwest. And so in the cooler climates, you may want to orient your house slightly towards the southwest to take advantage of a lot of that heat in the late day sun and capture the hotter times of the day. In the hot climates, you want to shelter yourself from the midday sun and possibly orient your house more to the east if you want to minimize the heat gain of your house. When we're looking at passive solar house designs, you do have a little bit of wiggle room. So you can orient your house completely towards the south and get maximum benefit from the sun's energy. Or you can orient it slightly to the southeast. So if we're looking at this, you can go up to 22.5 degrees either towards the southeast or towards the southwest. And when you do this, as long as you keep it within 22.5 degrees, sorry, that looks more like 45 degrees, but if you keep it just tilting your house like 22.5 degrees this way or this way, you'll still get, I believe it's about 80 to 90% of the efficiency that you would if you had it directed straight south. So there is a little bit of wiggle room when you're looking at orienting buildings anyways towards the sun. So we'll have to not only think about which way our house faces, whether it's our front yard, backyard, the house itself, but we also have to look at what altitude we're at as well. And this orientation is extremely important in our analysis, not just the elements, because the elements can be moved around, but you cannot change the direction that the sun is going to shine. You cannot change the elevation of the sun. You cannot change where it rises and where it sets. It is a fixed fixture that we need to work everything else around. Another thing that's very hard to change once you realize that it's there is the slope. So the slope has to be factored in, but unless you are going to build really extensive terraces, pretty much the slope is the slope of your land. So we need to position our elements based on what's best for each slope situation. So when you have too much slope on a property, so if the angle of your slope is greater than 18 degrees, then it makes the most sense to end up turning this all entirely into forest. That forest will help stabilize the slope and keep it from eroding, and you really won't be able to plant a lot of productive food production or anything on a slope that is that steep. Anytime that you absolutely have to plant on a steep slope, then incredibly complicated earthworks are necessary. Terraces are very difficult to build and maintain, and you are obviously going to need massive earth moving equipment too if we are going to terrace this entire hillside, and they really require a ton of work. So you're better off planting those steep slopes to forests and leaving all of the flatter land, so anything less than 18 degrees, to your crops and your gardens, because they're already conducive to that kind of growing environment. So when we connect the orientation, so which way the sun is coming from, and the slope that's on the property, and the elements, all of the properties of the elements, and the number of visits, if we do this right, we are always going to get a very good result.